Okay, in this video, we're going to be having a look at some trigonometry, having a look at sec, cosec, and cot, and specifically what these functions mean. Now, a lot of people will look at these and get a bit scared because we're used to seeing sine, cos, and tan, and now suddenly we're adding extra letters and extra words. But in reality, it's nothing too complicated. Each of these is simply the reciprocal of the functions that we already know. So, reminder on reciprocal means 1 divided by the function. So sec is simply 1 divided by cos. Cosec is 1 divided by sine. And cot is 1 divided by tan. Now obviously they will each have a variable in here. I will just add that in for consistency and to be thorough. But that is all these functions mean. They are simply 1 divided by cos, sine, and tan. Quickly, some people get a bit confused with how to remember which is which. There is luckily a nice and easy way. Just have a look at the third letter of each one. Third letter of sec is C, so it's going to involve cos. Third letter of cosec is S, so it's going to involve sine. And the third letter of cot is T, so it's going to involve tan. So if we were to just have a quick look at an example of what these mean, if I asked you to find sec of 90 degrees, or if you're following along with trig, you've probably been past radians now, sec of pi over 4, well, this is just the same as typing in 1 divided by cos of 90, or cos of pi over 4. Now, the eagle eyes amongst you may have noticed, or you might be putting stuff into your calculator, that if you put this into your calculator, you get a maths error. Because cos of 90 is 0, and you can't divide something by 0. And the reason I've put this in now is because in a second, when I start drawing graphs, this is something that we are going to have to get familiar with. So let's have a look at how to draw these 3 graphs. Okay, let's have a look at how to draw the graph of y equals sec of x. So 1 divided by, as a reminder, cos of x. So what we're going to do is we're going to take every point on my poorly drawn cos graph over here, just label that y equals cos of x so we don't get confused, and I'm going to flip it. I'm going to do 1 divided by that value. So let's start off up here. So at x equals 0, cos of x is 1. So on my new graph, and I'm going to kind of sketch it on here first and then translate it over so we can see it clearly and also quite rough, I'm going to end up with 1 divided by 1, which is still 1. So on my new graph, I'm going to draw it a little bit lower down here. You'll see why in a second. I'll just label that as 1. On my new graph, I'm still going to intersect here at 1. Now I want to draw your attention to down here, which is at 90. What happens at cos of 90, or when x is 90? Well, cos becomes 0, yeah? Cos of 90 is 0. So sec is going to be 1 divided by cos of 90, which is 1 divided by 0. And key theme is 1 divided by 0, no bueno, not very good, can't do it. What happens on a graph when we get to a place that is undefined with a 1 divided by 0 then? Well, we have an asymptote. So I'm going to draw it on this one here. We have an asymptote anywhere that my cos graph hits 0. That I'm going to have a 1 divided by 0. So that would be at 90 and at minus 90. So at 90 degrees and at minus 90, I will have an asymptote. Nothing's going to cross that line. So I know I'm starting here at 1, but what am I doing before I get to this asymptote? Well, let's have a think. Between 0 and 90, my cos graph gets lower. As x, we can write this, as x goes from 0 to 90, so it's very wonky when I write down here, that if I crouch down, it'll look weird. My cos of x goes from 1 to 0. So my sec of x is going to go from 1 divided by 1 all the way down to 1 divided by 0, basically, which obviously we know is impossible, but we can think of it as maybe infinity. I don't know if this is still the case, but a few years ago, if you typed 1 divided by 0 into Google, it would say infinity. I think it now says undefined, which is correct. But the point being, this number will get larger and larger and larger. 1 divided by 1 is 1. 1 divided by 2 is 0.5. 1 divided by 4, etc. gets smaller and smaller and smaller. But if my number increases, then it will get larger and larger and larger. So, if I'm getting it larger and larger and larger, when I'm inverting this, instead of going downwards towards 90, I will be going upwards towards 90. And it will look like this. I will essentially be getting closer and closer and closer to 1 divided by 0, closer and closer and closer to infinity, more or less. Now, we know a cos graph is mirrored, and the same logic applies on the other side, so it will look like this. Okay, what happens down here then? Well, again, nothing's going to be crossing 90, and nothing's going to be in this section either, because then we'll have a strange function. So, what happens here after 90? Well, we hit 0, and then we go up and up and up to 1. So this time we're starting at 0, going up and up and up until we hit, well, minus 1, but still technically 1. The number's getting larger and larger and larger, which means my reciprocal is going to get smaller and smaller and smaller. We're starting from our 1 divided by 0, our infinity, down here somewhere, and we are getting larger and larger and larger and larger until we hit our maximum, which is 1 divided by 1, which is here, which is 1. And that is at 180. Mirror that on this side, and we will have something that looks like this, repeated over and over and over again. It does get quite confusing. I've probably confused you a little bit more, but hopefully I haven't. The key ideas you need to remember is whenever our function is 0, so wherever it crosses the x-axis, our function is undefined. We're going to have an asymptote. Whenever it's 1, or minus 1, it's still going to be 1 or minus 1, because 1 divided by either of those things stays the same. But the last thing we need to know is, does it curve upwards or downwards? Well, it's going to do the opposite of whatever this graph here does. Now let's have a look at a sine. Okay, now let's have a look at a cosec graph. It's been a few hours, if you couldn't tell, since I recorded the last bit, because even though I've been doing this for 10 years, I still need a break from trig and graphs, and especially trig graphs. I mean, the Carabao Cup game I just watched was more interesting than this, but it's very useful, so we still need to know it. So, we've just seen how to draw a sec graph, a 1 over cos graph. Now, for cosec, first of all, just a reminder, third letter is S, which means it is going to be a 1 over sine x graph. Now, there's two ways that I can do this. I can either go about the whole rigmarole that I did earlier, look at my sine x graph that I've got here, and basically check each point for the reciprocal. So I know that I'm going to have asymptotes here and here at 0 and 180, because that's when my sine graph is 0. 1 over 0 we can't have. So I know there's going to be asymptotes, and I'll quickly draw them in. There's going to be one asymptote at 0 and one at 180. But there's actually a quicker way, without going through this entire thing. I know that in order to get from a sine graph to a cos graph, I just need to shift my entire graph 90 degrees to the left, right? This point becomes here, this point becomes here, etc., etc., etc. So I can apply the same logic to a cosec and a sec graph. They are both just translations of one another 90 degrees each way. So if I remind myself what the sec graph looked like, here's my sec graph. So if I want to get from a normal cos graph to a sine graph, I shift it 90 degrees to the right, and the same is true here. To get from a sec graph to a cosec graph, I just want to shift the entire, and that is my sec graph, 90 degrees to the right. So it's no longer hitting 1 at 0, it's now going to be hitting it at 90. It's no longer going to be down here at 180, it's going to be here. And I can complete that, and so on. So this is what, and that asymptote is at 180. Just make that a little bit more obvious. That's somewhat worse, but you get the idea, it's not an art lesson. All I need to do is shift it 90 degrees to the right. The same way I would translate a cos graph to a sine graph, I can translate a sec graph to a y equals cosec graph. And finally, we have probably the worst one of the bunch, as is usually true with tangent things. We have the cot graph, the 1 over tan graph. Third letter T, 1 over tan. So here I've got my standard y equals tan x graph with asymptotes at 90 and minus 90. And the question is, how do I inverse this? How do I get the reciprocal of this? Well, as usual, we're going to start by finding the asymptotes. We are going to have asymptotes, once again, wherever the graph crosses the x-axis, right? Wherever my tan of x function is 0, we're going to have asymptotes. And this is evidently at minus 180, 0, and 180. So I'm going to have asymptotes there on my center line and there. Okay, but then what is the rest of the graph going to look like? Well, once again, it's about taking limits and having a look at what happens with the function between these. So let me have a look between 0 and 90 here. What's happening on my tan graph? Well, tan x is starting from 0 and it's going all the way to basically being infinite. I'll do almost equal to infinity. It goes up and up and up and up and up and up forever. Yeah, there's no upper limit to where my tan x can go. So as I go from 0 to infinity, what happens to my reciprocal? Well, my reciprocal goes from 1 over 0 to 1 over infinity, which is, absurd. You can't do that. You can't do either of these things, actually. But we can get very close. 1 over 0 we know is going to be undefined, which is why I've got an asymptote at 0. But then we get closer and closer to 1 over infinity. So what happens in the limits as we approach 1 divided by infinity? By that, what I mean is, if I keep increasing the number on the denominator, what happens to the whole number? Well, as we've seen before, we would have 1, and then maybe a half, and then a third, and then a quarter, and then a fifth, all the way down to 1 millionth, and then beyond. We get smaller and smaller and smaller. We start off with essentially being at infinity. Remember, 1 over 0 is undefined, but infinity in this case is the limit of it is. We start off up here at infinity, and we get closer and closer and closer to 0. What happens when we get to 90? Well, at 90, we are at exactly, 1 over 0. We're at the old asymptote, which is 1 over infinity, because we never approach it, which is about 0. So I'm going to hit 0 at 90 degrees. And then you can probably see just from the shape what's going to happen, but let's apply the same logic. What happens after 90 degrees? Well, we start all the way down here at negative infinity, which is close to 0 when we reciprocate it. And we start up here, and then we get closer and closer and closer to 0. So when we reciprocate that, we get closer and closer and closer to infinity. And we end up with a graph that looks something like this, and this will of course keep repeating. Let's see if I can draw it well again. That might be simply atrocious. That one's nicer, but we will keep repeating the same idea over and over. And that's 5.5 hours later, is how to draw and how to understand a sec, cosec, and cot graph.